Good morning, everybody. Rise and shine. So here we go. We are doing 4.2, comparing quadratic relationships, and then I'll also be doing a couple examples on systems of three equations. I know that's kind of difficult. So here we go. I did an example. My questions are mirror images of the questions you're going to see in today's work, only this work is different, so you got to do this calculations all over again with the new given data. This is a jump pattern that my daughter follows and that I follow. Okay, have a little context for you because one of the book is about a frog, a flea, and a basketball player. So I thought I'll do a little different. I'll do my daughter Mia, who you guys have seen on plenty of my videos, and also myself. So these questions, I'm going to do some work here that I'm going to leave up for you guys, and then we're going to answer all these questions based on that data. Okay, because it's all about interpreting what these quadratic relationships look like. Also, pay close attention to my instructions on Classroom today because I have specified specifically what numbers of what parts to do today. So pay close attention to that so that you're not doing more than you have to. First things first, the question says find the maximum height reached by each. So we're going to do completing the square for each right now, and we're going to go from there, okay? So I'm going to do the first one, Mia, all right? I'm going to do Mia right here, all right? And I'm going to start doing completing the square by dividing out this negative 10 of both of these first two terms. So now this says negative 10 x squared minus x. I put the parentheses here, I put plus 3.75, okay? Well, I take half of negative 1, which is negative half, and I square that, and that's positive 1/4, okay? Now, I brought in, and I'll do this up here, I brought in a negative 10 times 1/4, and negative 10 times 1/4 is equal to negative 10/4, which reduces to negative 5/2. Okay? I brought in a negative 5/2, so I take out a positive 5/2, but 5/2 is the exact same as plus 2.5. Okay? So there's that. That's how I got plus 2.5. This is crucial, okay? Because now your final completing the square, your vertex form of this is negative 10 x minus 1/2 squared. 3.75 plus 2.5 is 0.25, 6.25. Okay, we'll answer these questions all in a minute. We'll do Mr. Weber now, aka me. So, quickly divide out the negative 8 of both these first two terms. So I get negative 8, and I get x squared minus 2x. Half of negative 2 is negative 1, squared is positive 1. Plus 6.25, and if I brought in a negative 8, I take out a positive 8. So my final form will be negative 8x minus 1 squared plus 14.25. Okay. Now, I want you to use decimals today because they're going to be definite. They're going to be good. This is a realistic example. So anyways, you can use decimals today. You don't have to worry about fractions. What is the maximum height reached by each? Well, when Mia jumps, and again, this is because we're Webers and we can jump like phenomenally. This is true. This is true data. And she's only 6 years old. Mind you, she can jump 6.25 feet. And what is the max height reached by each? I can jump 14.25. This is true. Very true. So that's what that means. Remember, you got to know which numbers we're using and why. Remember, if this was in vertex form, the maximum height would be positive 1/2 6.25, the x and the y, independent variable, dependent variable. Okay, you gotta always know what we're doing, why we're doing it. 1 comma 14.25. That's how I knew specifically which numbers I'm focusing on based on where this information is on the data. So there's that first question. Mia can jump a maximum height of 6.25 feet, and yours truly can jump 14.25 feet. White men can jump, apparently, according to Weber genes. When is the max reached? So when is the max reach? That is the time. That is the x variable. So the key here is pay attention to the wording. When and what. When is the max reach? Well, Mia reaches it after half of a second, and Mr. Weber reaches it after 1 second. Okay? How long does the jump last? So now this is where it gets funky. How long does the jump last? That means when you return back to ground zero. Okay? So when you're back to the zero, so now we got this data. Before I move on, I want to make sure I don't erase anything on purpose. So now that means we're solving. We're going to straight up solve. Okay? And as I'm doing this live with you, I'll just do Mia so I can leave this up and not rewrite everything. So we'll just do Mia, and then obviously follow the same steps to solve for me. Again, you'll see identical stuff in today's work. So, that said, how long does the jump last when they reach back to ground zero? So I'm going to erase me, and I'm only going to do Mia. Alright, so let's do Mia. We don't have to worry about this anymore. We know this is a maximum because it's a upside down parabola. So now if I want to solve, just set it equal to 0 and start solving. Minus 6.25 minus 6.25. I get negative 10. X minus 1/2 squared equals negative 6.25. I'm going to next divide out the negative 10. Okay? And I'm going to get x minus 1/2 squared equals, let's see, what is negative 6.25 divided by negative 10? And that answer is, 1 second, 6.25 divided by 10. I should have known that. That is 0.625. Now, we are using estimates, and this is okay, plus or minus, okay? So you're going to see what's going to happen here, and I'm going to, 1 second. All right, so when I take this, square root of this, I get plus or minus 0.79, and this is just x minus 1/2. Now I'm going to add 1/2 to both sides, or add 0.5 to make it easier. Add 0.5. Now there are two answers I can get here. Okay? Let's think about this. It doesn't make sense for us to worry about the 0.5 minus 0.79 because that's going to be a negative answer. We don't have negative times according to this, how long it takes to jump last. So we're only worried about doing 0.5 plus 0.79 because that's going to be the only realistic answer. And this jump lasts 1.29 seconds. That's how long it takes for Mia to jump in the air and jump back down after she reaches a max height of 6.25 feet. That is going to be the example that carries you for the, I'm sorry, I could finish answering this. What does 3.75 mean and 6.25? What do both of these questions mean? So this means how tall Mia is. This means how tall yours truly is, okay? The constants, where are they at when we're not jumping anymore? We're exactly this high off the ground, all right? And how is this represented in the graph? Well, if you were to visualize the graph, it's where these numbers are the y-intercepts, okay? We gotta get that through our head. The c's are always the y-intercepts of our quadratics, just like our b's are the y-intercepts of our linear equations. I'll be back in a few minutes with the systems of 3 equations. All right, here we go. First example of 2 that I'm doing for you today. All right, always look at your initial question and see which variable looks the easiest to eliminate, and then we'll start with that, and we're going to eliminate the s's first because I can see least amount of work. I'm going to do these 2 first off to the side over here. So I'm going to do negative 6r plus 5s plus 2t equals negative 11, and also 4r minus 5s plus 5t equals negative 4. And just we know these cancel, I'm left with negative 2r plus 7t equals negative 15. All right, next what I'm going to do is I'm going to multiply this middle one by 5 because that will make not positive 5, negative 5. Now, to be efficient with my space, I'm just going to put the answer right underneath it. Okay, this is nice. So I'm going to do 5 times negative 2, that's negative 10r, that's plus 5s, that's plus 20t, and that's negative 45. Just add straight up. We know that these cancel. I'm left with a negative 6r plus a 25t equals a negative 49. Okay? I want to put them underneath each other so I can see how they look. So I got negative 6r plus 25t equals negative 49. Well, this is easy. If I just multiply this top by a negative 3, I'll be able to successfully cancel off my r's. So just again, right underneath it to save space, I got 6r minus 21t equals 45. And I'm then left with 4t, equals negative 4. So then I divide both sides by 4. T equals negative 1. There's that first one. I got one variable out of the way, and I want to solve for r. Lower numbers, I prefer to do that. Let's just use this one. So now I got negative 2r plus 7 times negative 1 equals negative 15. Negative 2r minus 7 equals negative 15. I add 7 to both sides. Negative 2r equals negative 8, so r equals a positive 4. Divide both sides by negative 2. Last but not least, we got to solve for s. And I'm liking this one right here because this s has a coefficient of positive 1. So I'm going to use this. So I'm going to just go and put these numbers in place of r. I know negative 2 times 4 is negative 8 plus s. Negative 1 times 4 is negative 4 equals negative 9. Combine your like terms, I get negative 12 plus s equals negative 9. I'm going to add 12 to both sides, so s equals 3. This is one example directly off of the worksheet I'm giving you guys today, one I'm not going to assign, obviously. So that is this example. Hopefully this is making a little more sense now. I'm going to do one that's a little more intricate, and we'll be right back. Okay, last example. So this one's a little more intricate because the numbers are going to get a little larger, but don't be daunted by that. So first things first, I'm going to look at which variables I want to cancel. And because I got a 5 here and 2 negatives here, I'm going to use this against both of these, and I'll show you what I mean by that. So I'm going to multiply this by 5 and then write this over here. I'm going to then multiply this by 5 and bring this guy down here and see what I get when I do this. So when I rewrite this one, if I'm multiplying by 5, I'm going to get 5x minus 4y plus 2z equals 21. Okay? I'm also going to get a negative 5x minus 25y and then plus 30z equals a negative 120. Yes. So now when I do all my work, all right, I know that these cancel. I'm left with a negative 29y plus 32z equals a negative 99. Okay? Now, going down here, I'm going to do this math and then bring this guy right below it because I'm using this one again to eliminate this x. So now I got negative 5x minus 20y plus 25z equals negative 105. And now remember, just to do this, follow suit, negative 4y plus 2z equals 21. And we add them up, and these cancel, mission accomplished. Negative 29y plus 27z equals 105 minus 21 is negative 84. So now I'm looking at these guys, and hold on, this is a negative 24, right? Yeah, sorry about that. Negative 24y plus 27z equals negative 84. All right. Well, now we got giant numbers, and this ain't gonna be fun. So I'm gonna make my life easy. I'm just gonna multiply the top by positive 24 and the bottom by negative 29, so that whatever product I get here, they will, no matter what, cancel off. That's why I chose 24 and negative 29. So when I do that, I'm going to get a negative 696y plus 32 times 24 is 768z, and 24 times negative 99 is negative 2,376. That's a negative 2,376. When I multiply this guy across all of this, I get a 696y minus 27 times this is negative 783z. And negative 84 times negative 29 is 2,436. I add these up, and I'm going to get a negative 15z equals a positive 60. Negative 2,376 plus 2,436 is 60. When I divide both sides by negative 15, I get z equals 4. All right. Now, where do I want to solve for z? Heck, I'll just do it right here because it's got open space. So I got negative 24y plus 27 times, and this is a negative 4, equals negative 84. So now this says negative 24y. Negative 27 times this is negative 108. And this equals negative 84. So then when I add 108 to both sides, I get a negative 24y equals a positive 24. Okay? And when I divide both sides by negative 24, I get y equals negative 1. And last but not least, let's just use this one here, because who cares, right? I could just do one of these, but I'll just do this. So now I got a negative x. Negative 4 times negative 1 is positive 4. 5 times negative 4 is negative 20. That's a negative 20. Equals negative 21. Negative x minus 16 equals negative 21. I add 16 to both sides. We can see this, I believe so. Negative x equals negative 5. Divide that negative 1 coefficient off, so x equals 5. And there is everything. I will see you guys today in our Google Meets. You can ask questions there.